again. Hello, everyone. So it's been a while. If I'm correct, it's been like a year or more than 5 months, I guess. But we're going to continue yung rules of differentiation natin dito. So we're going to continue here in hyperbolic trigonometric functions with the application ng sum and difference rule of differentiation. So let's have a recall nga. So dito, ang sum and difference rule of differentiation ay ito. The derivative of f of x plus or minus g of x is equal to the derivative of f of x, wait lang ha, sinusunod ko pa lang, plus or minus the derivative of g of x. So in other words, if you have a group of functions that are separated by the addition or subtraction operation, you're just going to differentiate each of these functions. Okay? So, i-apply natin yan with hyperbolic trigonometric functions. So, let's just say we have this example. The derivative of sine hx minus cosine hx. Okay. So again, if we have functions that are separated by the addition or subtraction operation, we're just going to differentiate each of them. So therefore, we will have the derivative of sine hx or hyperbolic sine x. Ginawa ko lang sine hx para kumbaga mahaba kasing wording if you know what I mean. Next, minus then the derivative of cosine hx or hyperbolic cosine. Okay. So now that we already kumbaga transform natin ito into this expression, now what would be the derivative for sine hx and cosine hx respectively? So if you're going to recall earlier or last time that ang derivative wait lang mali lang ako ng pen color. So if you're going to recall last time that ang derivative ng sine hx or hyperbolic sine x or sine is hyperbolic cosine or cosine hx. And as for this one, which is the derivative of hyperbolic cosine x, ang sagot naman niya ay positive sine hx or hyperbolic sine x. Unlike dun sa sa trigonometric na cosine, ang derivative niya ay maging negative. Well, dito naman positive siya. So now we will now evaluate. So ang derivative ng hyperbolic sine x ay cosine hx or hyperbolic cosine. So this is cosine hx. Then minus here, derivative ng hyperbolic cosine, it is hyperbolic sine x. So we have this one. And this is our final answer. Let's try some few examples. Now for our next example, we will get the derivative of 3 tangent hx or hyperbolic tangent x minus 4 secant hx or hyperbolic secant x. So once again, according nga sa the derivative of mali pala ako. According nga sa sum and difference rule of differentiation, we're going to we're going to differentiate each of these functions that are separated by addition or subtraction operation. Hence, ilagay ko lang dito yung solution Hence, we will have the derivative of 3 times tangent hx minus sige, diretsoin ko na lang. The derivative of 4 times secant hx. Ayan. Also, if you recall that dun sa last time na tinuro ko, one of the basics ng indifferentiation is that if merong constant yung function, tapos nasa derivative notation siya, you can just bring it out. So, ibig sabihin nun, since we have 3 as a coefficient for this function, as well as 4 as the coefficient for this function, which is his secant hx, therefore, ilabas lang natin siya sa derivative notation. Hence, magiging 3 times the derivative of hyperbolic tangent x or tangent hx na lang minus 4 times the derivative of uh, secant hx. Ayan. So, siya na susulat ko. But at least it's readable. Now, we can differentiate. So, let's have a recall. What is the derivative of hyperbolic tangent x? Tama ba ako? Yeah, correct. Yeah. So, yun. Ang derivative nito is secant h squared x or basically hyperbolic secant squared x. Alright? Now, for the secant naman, ang derivative ng secant, secant hx pala, forgive me. Ito naman, you will have negative secant hx times tangent hx. Ayan. Yan. Okay, that's it. So, with that being said, we can now substitute or basically evaluate, Yan. So, basically evaluate na lang natin to. So, we have 3 times the derivative ng tangent hx, which is c, secant h squared x. So, we will have this one minus 4 times the derivative ng secant hx, which is negative secant hx times tangent hx. So, magiging quantity, negative secant hx times tangent hx. Yan. So, with that being said, Tori, so to simplify further, ito kasi si negative 4, tapos ito, may negative din siya. So, magiging positive sila. So, in other words, you will have plus 4 secant hx times tangent hx. Ayan siya. Alright? So, this could be your final answer. But we can actually, what do you call this one? We can actually simplify this one further. Pwede pa natin siyang i-simplify pa. You see, these two terms, they have a greatest common factor. Okay? We can factor out secant hx. Okay? So, kung ganun, ang mangyari dyan, we will have secant hx, secant to guys, this is not c, yan, times quantity, 3 times secant hx plus 4 times tangent hx. Ayan. So therefore, we can now leave this as our final answer. Para sa akin, pwede na to. But if you wish to convert it into hyperbolic sine and hyperbolic cosine, then it's clearly up to you. But for me, okay na to. All right, so this would be our last problem. So we will get the derivative of 4 all over hyperbolic sine x or sine hx minus pi times cotangent hx minus secant hx. So dito, as you can see, meron tayong 4 all over sine hx. So the thing is, kapag kasi may ganito, hindi na tayo gagamit ng actually, mayroong pagkasama difference kasi as you can see, each of the terms are separated by addition or subtraction operation. So yes, pero ito, to be particular, itong first term, you're going to use quotient rule. So, is there another way na dito kagamit ang quotient rule? The answer is yes, there is. And what would that be? By simplifying it. So dito, we can simplify 4 all over sine hx. Recall that yung cosecant hx is just the same as 1 all over sine hx. Okay? So, what does that mean? It means that, wait lang isulat ko ulit yung, yung given. It means that, kapag hinihiwalay ko si 4 sa gilid, we will have 4 times 1 all over sine hx, di ba? Ganito magiging itsura niya. So, 1 all over sine is the same as cosine hx. So, we can change this into cosecant hx. So, we will have this one. Ganito magiging itsura niya. O, di ba? Ngayon, hindi na siya nasa fraction, nasa denominator. It's already a whole function, whole term na siya. So now we can copy the rest of the terms. Wait lang nga, let me just rewrite this one. Okay. Now, we can apply yung sinasabi kong yung sum and difference rule of differentiation. So, we will have the derivative of 4 times cosecant hx minus the derivative of pi times cotangent hx. Then, last but not the least, minus the derivative of secant hx. Before we further evaluate this one, ay teka lang, bakit may extra sa gilid? Yan. Before we further evaluate this derivative, we notice that merong constants itong dalawang terms or first two terms. Which is ito, una, meron kang 4 cosecant hx, so mayroon kang constant. And the same thing here as well. We have pi. This one is not a variable, it is a constant. Okay? Itong pi na to, hindi to variable, constant lang siya. It represents an irrational number. Itong irrational number na to, meron siyang kasing continuous decimal value. Okay? If you remember correctly sa diniscuss kong video about constants. Alright? So, yeah, going back. So, if we have a constant, tapos meron kang function, anong gagawin natin? According sa tinuro ko noon, ilabas natin siya sa derivative notation. Hence, we will have 4 times the derivative of cosecant hx, yan, minus pi times the derivative of cotangent hx, then last but not the least, secant hx. Okay. Now we can now basically, what do you call this one? Yeah, evaluate. So what is the derivative of cosecant hx? So recall that ang derivative ng cosecant hx, so ko lang siya dito is negative cosecant hx times cotangent hx. Ayan siya. Okay? Now, how about naman kapag kay cotangent hx? So kay cotangent hx or hyperbolic cotangent x, this is basically negative cosecant h squared x. And last but not the least, yung derivative ng secant hx, if naalala nyo kanina, ang derivative ng secant hx ay this is negative secant hx times tangent hx. Yan siya. So now, pwede natin siyang i-evaluate. So for the first term, 4 times the derivative of cosecant hx, you will have 4 times quantity negative cosecant hx times cotangent hx minus sa pi naman, pi times the derivative, wait lang the derivative of cotangent hx, which is negative cosecant, negative cosecant h squared x. Then last but not the least, minus the derivative of secant hx, magiging quantity, negative secant hx times tangent hx. Yan. So now we can simplify. So sa first term, we will have negative 4 times, wait lang, ayusin ko lang tong, yan. So we will have, once again, negative 4 times cosecant hx times cotangent hx. And here, sa second term, minus pi times negative cosecant h squared x. So magiging plus pi times cosecant h squared x. Then, last but not the least, minus negative secant hx tangent hx. So magiging positive to. Remember, negative times negative is positive. Ayan. So it seems like this is already a good answer or valid answer na to. But we can still simplify. You see, itong first two terms, meron silang greatest common factor na cosecant hx. Tama ba ako pagka? Yeah, tama. So we can factor it out. So with this, we can have quantity. Wait lang. So we can have quantity negative 4 times cotangent hx plus pi times cosecant hx, then times cosecant hx, then copy the rest of the terms or terms that are not included in factoring. And there we go. You can simplify this one further kung ba gusto mo siya convert to a hyperbolic sine function at saka hyperbolic cosine function. It's up to you. Okay? But for me, okay na to. This is already a valid answer na. Alright? So there we go. So thank you sa discussion natin for today. And now we're going to mali pala ko. The next video naman ang pag-usapan natin is we're going to apply hyperbolic trigonometric functions sa differentiation, to be particular, application ng product rule of differentiation. Alright? So see you next time. And yeah, I think that's it naman. So yeah, see you